It is, ain't it? All right. So guys, let's let's jump into the rectangle problems first because I think they're a little more easier because you can draw a picture. Okay. Now let's look at number 4. It says the length of a rectangle is 5 feet more than its width. If the area of the rectangle is 36 square feet, what are the dimensions of the rectangle? Okay. Now, guys, it's not all about knowing like what the dimensions are. It's how you're going to set up the formula. Because a lot of times, guys, the ones I've seen on the test, you have to know how to set up a formula for it. Okay. So stuff like this, guys, you need to draw a picture for it. Now you're going to draw a picture. Now, guys, a rectangle. I ain't no artist, so that'll be all right. Now, guys, notice it says the length of a rectangle is 5 feet more than the width. Okay. All right. So what you need, guys, you can't have two variables. Okay. So we're going to have to use one variable and and then get two lengths out of one variable. Okay. Now, so what I would do, guys, notice it says the length is 5 feet more than the width. What I would do, I would start with the shortest side. Now, guys, everybody, if the length is 5 feet more than the width, that means the width is the shortest side. Width is this way, right? This is the width, okay? So now we're gonna let it be. We're gonna let that be W. Okay, we're gonna let the width this be W. Man, won't you pay attention, man? Quit paying attention to that. How about that? All right. So guys, if this is the width, now guys, remember, I can't use two variables, so don't put L down here because it'll mess it up. Okay, you're gonna have to use it in respect to W. Okay, now here's the width. If the length is 5 feet more than the width, how can I write that in terms of W? W plus 5. 5 feet more than the width. If you want to add 5 feet to something, you just add 5 to it. Okay. Now, guys, it says the area is 36 square feet. Now, guys, area. Now let's go back to something really, really simple. Area is length times width. Okay. So now let's fill this in. Now, length. Let me do this. You don't have to change yours. I'm gonna change mine because it makes it a little easier to distribute. So it's width times length. Okay. Now my width is W. So my width is W. Okay. My length is W plus 5. So there's my length. Okay. So, and guys, with this being set side by side, we know we're multiplying. Okay. Okay. And it says the area, well, guys, the area is already given to us is 36. Okay. Now, guys, what I'm more concerned with is not necessarily getting the dimensions here. I'm just wanting to see if you can set up a quadratic equation to give that would give the length, all right, or give the area. Now, guys, we're multiplying here, okay? So I'm going to distribute that to here and here. So what's W times W? W squared, right? Now, W times 5 is 5W. Now, guys, what we're trying to do is we're trying to get dimensions, okay? So now, remember, W is a dimension, that's the width, okay? So now, anytime you're solving, for whether it be X, W, this is called your independent variable. This is your independent variable, okay? If you've never heard that before, that's what your X is called. Your Y is your dependent, okay? Now, anytime you're solving for your independent variable, you got to have it equal to 0. Okay, so that's w squared plus 5w minus 36. And that's going to be equal to 0. Now, so guys, tell me some ways I can solve this. We've been doing this the last few days. Just quadratic formula, you can factor. Let's do quadratic formula since quadratic formula will do anything, okay? So now, tell me what my A is here. It's 1. What's my B? 5. And what's my C? Negative 36. Okay? So now, that being said, plugging it in, X equals. Now, guys, it's the opposite of B. So if my B is 5, it's going to be negative 5. Plus or minus. B squared. Well, what's going to go here, guys? Or what's going to go in the parentheses? 5, right? If it's negative, it has to. Positive, you don't have to do it, but I always tell everybody to do it anyway. That way you don't get confused on which. I always tell you to always put it in parentheses. All right, now, guys, A goes here. So what is my A value? 1. C goes here. What's my C? Negative 36. All over 2 times what goes here? 1. Good. Now, guys, me and Rob and I have said this to her blue in the face. What do I calculate first? The discriminant. Good. Whoever said discriminant, that's awesome. So this is my discriminant. Who said that? Awesome. Yeah, Bonds, yeah, she pulled it out. All right, now. So, guys, I'm going to calculate my discriminant. Now, I'm going to put everything in parentheses. 5 squared minus 4 times 1 times negative 36. All right, now, press enter. So now what we have, guys, is this. X equals negative 5 plus or minus the square root of 169 over 2. Now, the next thing we need to do is see if this is a what? Perfect square. Okay, so now let's do that. So second x squared, that brings up the square root. 169, that should be 13. So there you go. So now it's going to be x equals negative 5 plus or minus 13 over 2. Everybody pretty good with that? Okay, so now that's going to give me two answers. That's going to give me x equals negative 5 plus 13 divided by 2, and x equals negative 5 minus 13 divided by 2. And the reason I got two answers, guys, is because I'll have a plus and a minus. The plus and the minus comes to when you derive the quadratic formula, when you take the square root, it's plus or minus. So that's where the plus and minus comes from. That means you have two answers. Now, if I do this, that's going to be x equals 4. Okay. Negative 5 plus 13 is 8, divided by 2 is 4. Now, negative 5 minus 13 is negative 18. What's negative 18 divided by 2? Now, one of these answers is a strenuous solution or cannot be used. Which one is it? Negative 9, because distance or length dimensions cannot be negative. So that guy will not work because it cannot be negative. You guys, no such thing as negative length or whatever. So now this is our answer. So now what it wants is the dimension. So what I'm going to do, I'm going to go back up here to my, now guys remember, I used X, but it's supposed to be W. W6, excuse 4. W's 4. So now my width then is going to be 4. And now if I plug this in, 4 plus 5 is what? Now does 4 times 9 give me 36? It does. So was 4 the right answer? It was. Plug the W in right here, which is 4. 4 plus 5 is what? Yeah. What y'all think about that? It seems like it's a long process because I'm going through each step, but it's really not too bad. Um, let's look at number 7. All right. So guys, we're talking about a triangle, okay? So now I'm just going to draw a right triangle, okay? Now, okay, it says the base of a triangle, um, the base of a triangle is 5 feet longer than the height. Okay, now, guys, this is the base down here, right? That's the base. That's the height. Okay, that's the base. That's the height. Okay, now it says the base of a triangle is 5 feet longer than the height. Okay, so which one's longer, the height or the base? The base is longer, right? Always let your variable be the shortest side. Okay, so now if the base is longer, I'm gonna let height be H. I'm gonna let height be H. Let the shortest side have the variable, the single variable with it. Okay. Now there's already some exceptions to the rule, um, but we most of the time if you let the shortest side be the variable, usually it works out pretty good. Okay. All right. Now, guys, it says the base of the triangle is 5 feet longer than the height. So how do I show that? H plus 5, right? H plus 5. It's 5 feet longer than the height. If the height is H, it's just H plus 5 because it's 5 more than the height. Okay? Now, it says the area of the triangle is 42. So now, first thing we need to do is we need to get what the formula of the area of a triangle is. Okay? So now, the area of a triangle is base times height divided by 2 gives me the area of a triangle. Okay? Now, so we need to fill this in. Which expression is B? H plus 5. What is the expression for height? H. And guys, it's going to look a little funny, but we can still work with it. All right. What is the area that's given to us? 42, right? All right. Now, first thing I'm going to do, I'm going to distribute the H here. That's going to be H squared plus 5H if I distribute my h, it's h squared. H times 5 is 5h. Okay. And the divided by 2 is in your formula, so that's where the 2 came from up here. And the area, it was given to us in the problem. Okay. Now, my variable is tied up in this fraction. How do I get rid of a fraction like this? You multiply it by the bottom. Okay, so now, if you want, in that case, what's on bottom is a 2, so I'm going to multiply it by 2. Guys, these will always cancel. That every time you do that, it will cancel. But this one right here, okay, I'm trying to get rid of the fraction. Whatever number this is, Jacob, you're going to multiply both sides by that number, and they will always cancel. There will never be a time these don't cancel. Yep. And then you'll just be left with your numerator. All right, so now that's going to be h squared plus 5h equals 84. 42 times 2. Remember when I multiplied on this side? I got to multiply by 2 on this side. All right, now, can I solve this the way it is right now? No. What do I need to get it equal to? 0. So what I need to do is I need to get this over here. You could complete the square on it, but we'll stick with one way. Guys, one thing about these, and you don't have to factor if you don't want to, most of the time all these will factor. Matthew, y'all pretty good with this stuff? Beaver, y'all pretty good with this stuff? That's all right, man. Jeremiah, you all right with this stuff? Okay, man. All right, now, so let's pick out our letter. We're going to use a quadratic formula. A is 1. What's B? 5. What's C? Negative 84. All right, now, X equals. What goes here is the opposite of B, so that's going to be negative 5 since it's positive, plus or minus the square root Bo, I'm getting ready to ask you a question. What number goes here? Well, it is the B, but that is a positive 5, right? So that's 5. Gina, what goes right here? Yeah. It's 4 times A times C, right? So it's 1 and negative 84. All right? Over 2 times 1. Okay? Now, so what I'm going to do now is I'm going to figure out my discriminant. I'm going to put everything in parentheses that I plug in. So 5 squared minus 4 times 1 times negative 84. That's 361. X equals negative 5 plus or minus the square root of 361 over 2. Now, let's see if 361 is a perfect square. It is. It's 19. Okay, so now that's going to be x equals negative 5 plus 19 divided by 2, and x equals negative 5 minus 19 over 2. Okay? Now, if I do my arithmetic here, that's going to be x equals negative 5 plus 19 is 14 divided by 2. That is 7. Negative 5 minus 19 is negative 24 divided by 2, which is negative 12. Which one of these is a extraneous solution? It can't be used. Negative 12, because it's a you can't have negative dimensions, right? So now the dimension I need is 7. So it says we need the base and the height. So now my base is h plus 5. So guys, if I know what h is, it's 7. That's going to be base is going to be 12, and then my height is simply going to be what? 7. Your base is 12. And the reason why it's 12, my fault. I just 7 plus 5. Yep. Because it said that the base is 5 more than the height. If the height is 7, then the base has to be 12 because it's 5 more. Mm-mm. If it's a negative number, don't have it. Don't do it. All right, guys. Why don't y'all try number 5? Try number 5 and see what you can do with it. All right, so we did number 5. Okay, so it was a rectangle problem. It's a rectangle problem. All right, now it says the width of a rectangle is 3 feet less than the length. All right, it's 3 feet less than the length. If the area of the rectangle is 88 square feet, the area is 88 square feet. What are the dimensions of the rectangle? Guys, we're up here. You should not be talking to each other. Now, guys, notice that the width is referenced back to the length. So whatever one is referenced back to, that's the one you're going to let be your variable. So in this case, it says the width of a rectangle is 3 feet less than the length. Well, here's the length, and then the width is 3 feet less than the length. So that's going to be the length minus 3. Okay? So L times L minus 3. Now, so that's going to be L times L minus 3 equals 88. All right, now, if I distribute that, that's going to be L squared minus 3L equals 88. Now, I need to get it equal to 0, so I'm going to subtract 88 from both sides. That's L squared minus 3L negative 88 equals 0. Now, going to the quadratic formula, x equals, now, guys, my A is 1, my B is negative 3, my C is negative 88. All right, now, so it's x equals 3 plus or minus the square root of negative 3 squared minus 4 times 1 times negative 88. All right, guys, what was the discriminant on this? Anybody know? It was 361. Okay, so that's going to be x equals 3 plus or minus the square root of 361 over 2. Square root of 361 was what, 19? All right, so 3 plus 19 divided by 2 and 3 minus 19 divided by 2. All right, so now, that being said, 3 plus 19 is 22. That gives me 11, okay? And then 3 minus 19, that gives me negative 16. over 2. That gives me a -8. Now, which one of these is the extraneous solution? -8. Extraneous solution means you can't use it. That's what it means. The one that's no good. All right, now, so that being said, L is 11. If I plug in 11 here, this is 8, so your dimensions are 8 by 11. And if you multiply those guys, that gives you 88. You can always check it, okay? All right, let's we've pretty much, how many have we done? 3 so far. Let's go do some integer problems. That was number 5. All right, let's look at number 1. Now, guys, first of all, does everybody know what an integer is? Okay, an integer. Let's do a little math history real quick. Okay, now when when the number system was first, we used base 10 number system. When it was first created, all they did was use the. All right, so they use these are what the numbers like 1, 2, 3, and 4 are called counting numbers. Okay, that's why they were called. It was called counting numbers. Well, then they said, well, what happens if we don't have anything? What's going to be the number for it? Well, then they put 0 on here. They call those whole numbers. Okay. Well, then as they got further into math, they started noticing they had negative numbers. They would have negative numbers such as -3, -2, -1, 0, 1, 2, 3. Well, they said, what are we going to do about the negative numbers since we're starting to get those? Say we're going to call these guys integers. Now, an integer can be a positive or negative number, but no fractions or decimals. So, guys, if somebody ever asks you what an integer is, it is a number. It's a positive or negative number that has no fractions or decimals with it. Okay, integer can be any whole number that is a negative or a positive, including 0. Okay, so now let's talk about. So, guys, if you have an integer problem, are you going to get a decimal? No, you can't have decimals because integers do not encompass decimals. Okay, that's when you go to rational numbers. All right, now, so let's talk about number 1 real quick. Now it says find 2 consecutive integers whose product is 72. Okay, now let's try something real easy so we can get our formula down. Okay, now 1, 2, and 3 are those consecutive integers? They are 1, 2, 3. Now, to get our formula we're going to use, we're going to use some variables. Okay, I'm going to let my smallest one be x. Okay, I'm going to let my small number be x. Okay, so x is smallest. Now, to get if I ask you, what do I have to add to 1 to get to 2? What would you tell me? 1. So the next number, your middle number, is going to be x plus 1. That's how you get the second number. Okay? So x plus 1 gives you the second number. And it's not these expressions are always true how it works. Okay? Unless you have odd or even, but it's the same thing. I'll show you one of those in a minute. Now, how am I going to get 3? How am I going to get my largest number? It's going to be what? Be x plus 2. Because remember, guys, we addressed 1 as x, right? This is just a simple illustration to kind of drive home what we're going to be doing, okay? So x is 1, 2 is x plus 1 because it's the next integer. 3 is x plus 2 because it is the biggest integer, okay? So now, guys, these three expressions, x plus 1, and x plus 2, work on about anything you're going to work on as far as consecutive integers. If you see something about consecutive integers, this is going to be a part of your. This is going to be some part of your formula. Okay. Now, find number 1. So it says find 2 consecutive integers whose product is 72. Now, first of all, what is when you what math operation do you do when you get a product? You have to multiply. Multiply equals product. So since it's the product, we know we're going to be multiplying these two integers. Okay. Now, what am I going to address the smallest integer as? What am I going to address? You're going to address it as x, right? Now, if we're only talking about only two numbers, am I going to use x plus 2 at all? No, because you're only dealing with two numbers. It's going to be this and this. So how am I going to address the largest number? There you go. So x, and the reason I'm multiplying because it's product, x times x plus 1. Smallest, biggest. There's only two numbers, right? You have a smallest number and a biggest number. All right, now, and the product of these two numbers is what? When I multiply these two on 72. So now, if I'm multiplying, that means the same as distributed. So that's going to be x squared plus x. And then I've got to get it equal to 0. So what do I do with this 72? You subtract it. I'm going to subtract it from both sides and get this. This is factored really easy, but we're going to use the quadratic formula again. Okay, now, my A is 1. What's my B? 1. What's my C? Negative 72. So that's going to be x equals negative 1 plus or minus the square root of 1 square 1 squared minus 4 times 1 times negative 72. All over. What's 2 times 1, guys? 2. So I'm not going to do that, okay? Now, if I do my discriminant, that's going to be 1 squared minus 4 times 1 times negative 72. 289, okay? So now, I need to see if 289 is a perfect square. So I'm going to do second x squared and pull up my square root button. 289. It is 17. So what we have is this. X equals negative 1 plus or minus 17 divided by 2. Okay? Now, let's split this up. That's going to be x equals x equals -1 plus 17, that is 16. That's 8, right? All right, now, we also have -1 minus 17, which is -18, divided by 2, which is -9. Now, this is an important question here. It says find two consecutive integers whose product is 72. Now, can integers be negative? It can. It can be negative. So now, guys, think about it. If x is 8, right? If we're going back up here, if x is 8, if I plug in 8 here, what's my other number? 9. That's one answer. Okay? But now, we agree that integers can be negative numbers, right? It didn't specify positive integers or anything. So now, if I plug in -9 for x, what's -9 plus 1? -8. Guys, if I multiply 8 times 9, will I get 72? Yeah. 8 times 9 is 72, right? That's the product of it. If I multiply -9 times -8, would I get a 72? Yes, because two negatives is a what? A positive. That's your answer. So you'd have two sets of answers. Guys, I will post this video on Google Classroom in case you want to go back and look at it. Um, let's look at number 2. All right. It says find two consecutive even integers whose product is 24 more than 8 times the larger integer. Okay, now, guys, looking at number 1 and number 2, what's going to be different about my integers here? They got to be even, right? They have to be even. So let's talk about that just a minute. Does everybody agree that these three numbers are even numbers? Okay. What the smallest number is 2, so I'm gonna let him be x. Okay. Now, be careful here. What do I have to add to x to get to the next even integer? 2. What do I have to add to x to get to the next even integer? 4. So guys, we're going to use these in our next formula. Okay. Now, we only need two consecutive integers. So am I going to use this one at all? No, because I'm only looking for two integers. If it said 3, then I'd probably need to use this. But you only need 2, so you're only looking at these two right here. Okay. Now, it says find two consecutive even integers whose product is 24 more than 8 times the largest, whose product is 24 more than 8 times the largest integer. Okay, now, so if we're doing product here, now guys, how do I show product of two integers? I'm gonna do x times x plus 2. Okay. Now guys, it says find two consecutive even integers whose product is. What does the word is imply when you're writing equations? Is means equal, right? All right. How do I show Aiden? How do I show 8 times the larger integer? Now remember, this is the largest integer. This is the smallest integer. How do I show 8 times the larger integer? Be 8. Since it's the larger, it's going to be x plus 2, right? Because this is the largest one, right? 8 times the largest integer, right? Does everybody understand why I put x plus 2? Because that's the largest one. Now, how many more is this integer than this one? It is 24 more than. So that means I want to add 24. Because it says whose product is 24 more than 8 times the larger integer. Okay? Now, guys, since I gave you the formula, I want to see if you can solve this. Okay? Jeremiah, Luke, we're going to try to solve this right here, man. Guys, here's your formula. This is the hardest part. I want to see if you can solve it. This will be a quadratic. Okay?